It's been long accepted that CO2 in our atmosphere, released as a result of burning fossil fuels to power our factories, transportation and homes, is contributing to climate change. Whichever way you look at it, driving petrol-driven cars puts a huge amount of carbon dioxide into the atmosphere. But what if you took that carbon dioxide and turned it from a problem into a solution? Professor Camille Petit is a materials engineer who's developed a filter that can detect and absorb even the tiniest amount of CO2 in the air. One of the biggest problems is the fact that transportation contributes so much carbon dioxide into the atmosphere. What is your research doing to address that?
In our case, we are looking at technologies that can capture CO2 from anywhere. We're not looking at a specific source of CO2, we're just looking at CO2 that is already present in the atmosphere and targeting those very dilute concentration, but still very important for the planet. We're using what's called an adsorbent. So basically, an adsorbent is like a sponge, and it's going to be able to distinguish between molecules that are CO2 versus molecules that are not CO2. And the molecules that are CO2 molecule is going to grab.
And is it actually a sponge?
It works more like a Brita filter.
So are you saying that the technology may help to mitigate carbon dioxide in our atmosphere is actually in our kitchen?
The principles are exactly the same.
So this is actually full of beads.
It's full of beads, yeah.
And what material would that be?
What's called ion exchange resin or activated carbon, so it's charcoal basically, or polymers.
In terms of the grains that are in here, how do you select what's best for detecting CO2?
So you know about the chemistry of CO2. So we know it's acidic, we know it has already certain affinity for some atoms, so we would make sure that our adsorbent has, that chemical affinity. And what you see inside is another version of this, another version of the sponge that has been embedded into that big disc. And the idea, you can see there is some holes, is to make sure that the air can flow through with the CO2 being captured.
So this is an example of the sponge-like material being applied to an actual device that will filter the CO2 out.
Yes.
Absorbing CO2 already in the atmosphere is one thing, but factories and power stations continue to burn fossil fuels. Dr. Colin Hale is working on an ingenious way of catching that CO2 before it escapes into the atmosphere, and how this could result in even greener transportation.
So this is a pilot-scale carbon capture facility. It's replicating the sorts of process that you would use for example, removing carbon dioxide from the flue gases coming out of the chimney of a coal or a gas-fired power station. It's about capturing the carbon dioxide before it goes into the atmosphere.
Why is a plant like this so necessary for us today?
I mean, one of the key challenges we've got is, on a global basis, we're emitting of the order of around 90,000 million tonnes of carbon dioxide per year. And one of the key challenges we've got is to reduce those emissions, because as you're aware, carbon dioxide in the atmosphere is causing us some quite significant issues.
Can you show me how that works then?
And the way that it works, when carbon dioxide gets wet, it becomes slightly acidic. We can use an alkaline solution to react with it to remove it from a mix of other gases.
It's such a simple concept of dirty carbon dioxide and other gas going in and pure carbon dioxide coming out, because we often see carbon dioxide as being this terrible gas, but actually it's a really useful ingredient for other things. So these two columns here are crucial for this fairly simple process to happen. I don't know if you can see this clearly, but what I'm looking at is rain inside a pipe, essentially. And it's where liquid meets CO2 gas, and the reaction that happens between them is really where the CO2 is captured. And why this is so essential is because this is the first step in making sustainable vehicle fuel. This captured CO2 is used to produce synthetic vehicle fuel. Professor Nilay Shah, a process systems engineer, co-founded Zero Petroleum, a company driving motorsports in a much more sustainable direction. Is the synthetic fuel that you are developing actually performing as well as petrol?
Yes. In fact, what we do is we check the chemistry first of all. So we check what we've made by doing a lot of detailed chemical analysis, and we can see it's as good as existing fuel. In fact, we would say it's better because it doesn't have impurities in it.
It's quite fascinating to think that motorsports, for example, could be leading the way, encouraging the development of this technology.
From a performance point of view, what's nice about making a fuel from building blocks is you can actually make a designer fuel, and you can actually make it better for the engine. So you can actually have better performance as well. You can design some specific features into the fuel to make it a high performing fuel. I think motorsports is a really good example, because I think first of all they are pushing for being more sustainable, and secondly they've always been very good in developing new technology. So they've always been advancing engines and control systems and brakes and all of those sorts of things. So they have a history of adopting innovations. So it'll be very easy for them to adopt a new type of fuel.
What I love about what I've seen today is we acknowledge that we've been creating a problem. We've been burning fossil fuels, releasing CO2 into the atmosphere. But what I saw today here at Imperial really shows that we're taking the problem and we're turning it into a solution. And that's really where engineers can make such a massive difference.